everyone, welcome back. Today we have 2870, a minimum number of operations to make array empty. It says here that we're given a zero index array nums consisting of positive integers. There are two types of operations that you can apply on the array any number of times. It's either choose two elements with equal values and delete them from the array, or choose three elements with equal values and delete them from the array. And we are trying to minimize the number of operations required to make the array empty. And if we're not able to do that, then we return -1. Now, the main thing to note is the order of the numbers does not matter. So if a number appeared like 1, 2, 1, or 1, 1, 1, or 1, 1, 2, the order doesn't matter as long as we can delete the two equal numbers, and then if we had another, or the three equal numbers. And if we're not able to delete 2 or 3 at a time, if we're left with 1, then we return a -1. Okay? And we are trying to minimize the number of operations. So the way we can think about this is if we want to minimize the number of operations, we can do either 2 at a time or 3 at a time, and anything with 1 is -1, we basically have two conditions. Either it's valid, where we can delete, or invalid. Now, invalid is if there's only one remaining. If it's 1, then you return -1. Now, if there's 2 or 3, we really want to optimize with the minimum number of operations, so we can favor the 3, because anything that's divisible by 3 contains a 2, and the way we can think about it is, so 1 is invalid, 2 will return 1 operation, this is -1, 3 will return 1 operation, 4 will return 2 because we can include 2 2's, or if we think about using the 3 can use a 4 and have 1 remainder. Then we can basically borrow from the previous guy to make this either a 2 or a 3. So 3 goes into 5 once. Alright, so 3 goes into 5 once, and then there's 2 left over. Now we can borrow from the 3, or not. We don't have to, because once is a 3, the remainder is a 2. 2 and 3 are both valid, so this returns 2 operations. Okay, so this is getting a little messy, so why don't we do it like so? So let's take a valid example here. So we have this as our first example. We can borrow that here and say, you know what, we really don't care the order, we really only care about the count. And the way we can keep track is by taking every number and counting its frequency. So let's say we have, this is a 2, 2 has a 1, 1, 2, 3, 4. We have 4 2's. And for 3, we have 1, 2, 3 3's. And 4, there's 1 and 2. Okay? And then we can say for every number, so for every number and its count, we can check if the count can be divisible by 3. We take the maximum number of operations possible. So 3 can go inside 4 once. So at this iteration, 3 can go inside once. We have remainder of 1, and so we can say, we can add this guy and whether or not there's a remainder. So there is, and it doesn't matter if the remainder is a 1 or a 2, because it's a 3, 1, 2, 3, it will have either fit exactly by taking the 3, or it'll have 1 or 2 as its remainder. So 1 plus, if it has any remainder, it's a 1, so that's 2. All right, now we take this guy. 3 is divisible, or 3 can go into 3 once exactly. There's no remainder, so the operation is exactly 1. Now for this guy, it's a 2. 3 cannot go inside 2, but there is a remainder, so the operations, total operations is 1. 2 plus 1 is 4. So as we can tell, we have 4. Now, let's say that this actually had another 1. Then we would say, hey, if there's only 1, then we return -1 because there's no valid way to group this into 2's and 3's. The main idea, the tricky idea, is that because we're optimizing with the minimum number of operations possible, and 3 is just 1 plus 2, we can just use 3 alone. 3 alone to get the minimum number of operations that's divisible by 3, and then whether the remainder is a 1 or a 2, let's say the remainder is a 2, well, both 2 and 3, right? 2 and 3 are valid divisors, so that works. We can take the 3 and the 2. Let's say instead that the remainder is a 1. You know what? That's okay too, because then we can borrow 1 from 3. So this becomes a 2. This becomes a 2. 2 and 2 is also valid. So however large the number becomes, as long as we optimize with 3, whether there's a remainder, if not, if no remainder, we just take the count as is. But if there's any remainder, whether that's a 1 or a 2, then we can assume that the additional operation required is 1. We need 1 additional operation. Okay, I hope that made sense. So let's go over the code. The code, so we did what? We did counts. We took the count of nums. So for each number, we get its frequency. And then we ultimately want to return the total number of operations required to divide by either 2 or 3 equal elements at a time. So we initialize that at 0. And then for every num in, let's say, counts in counts.items, if the count, first of all, is 1, if the count is 1, and remember all the numbers are positive, if the count is 1, then we can't group it into 2's or 3's, so we return -1. Now, otherwise, it means it's either divisible by 2 or 3. So, and we want to optimize returning the minimum number of operations. So let's first add to the number of operations. However many times 3 can go inside this count evenly. Okay, we add that, and then we say if there's any remainder, whether that's a 1 or a 2, 1 or a 2, then, and we check if there's a remainder by doing, if count modulo 3, if that returns a non-zero, that means there was some remainder. And so if there is a remainder, then we add another operation to account for the remainder. And believe it or not, that's just it. And then we return the total number of operations. Let's give that a run. And submit. Okay, and there you have it. So this is the main idea. The real main idea is that there's only 2 scenarios. It's either valid or invalid, first of all. And if it's valid, it must be either 2 or 3. But because we're optimizing, we always take the 3, and however many times it's divisible by 3, that's awesome. We're, optimizing. But let's say there's any remainder, then Whether that remainder is a 1 or a 2, we can make this valid by either taking the 2 as is, because 2 is also valid, so we take the 3 and the 2, 2 is valid, or let's say it's a 1, that's okay, we borrow from the previous 3, make this into a 2, and then this into a 2 because we added 1 from here, these becomes 2 and 2, and that's also valid. So whether the remainder is 1 or a 2, we add exactly one operation. Okay? And this was once again 2870, minimum number of operations to make array empty. Thanks so much. Happy coding. See you next time.